Good afternoon. So today we're going to study yet another formula for counting stuff. This is the so-called multiplication principle. Um, Many of these formulas have these fancy names, but I don't know if they actually deserve a name. If you really think about how you actually count the possibilities given the problem, it does have a logic to it. So actually, with a little practice, you don't even need to actually call it multiplication principle. You don't even have to think of it as a formula. In fact, I strongly advise you not to think in terms of a formula, but to actually understand it logically why that's the case. And we're going to write it like a formula or a general principle as the lesson indicates. But let me illustrate why you can actually answer the questions in this section without knowing that what you're doing, you apply the multiplication principle. So let's start with two examples. So suppose that in a restaurant, again, to simplify all the options here, suppose that you want to get a main course and a dessert. And let's say that the main course has the following options. So you can actually get chicken, let's call it C to refer to it faster later. You can get something with beef or pasta. And for the dessert, you have a choice between ice cream and then fruit. So these are the options. So if you notice here, what we talk about is basically a task. The task here is essentially choosing the entries. And again, the limitation is that you're going to choose two of them, main dish plus dessert. But each of these entries has various options. You have three options in the main course, and you have two options in the dessert. So the question is, how many combinations or how many possible combinations of an entry? I shouldn't call it entry because an entry means just one of the two, right? The main course or the dessert. So how many combination of dining, let's say, right? I mean, your dining experience will consist on a main course and a dessert. How many combinations can you have given these choices? So let's actually write them down. Now, notice each of the entries in the main course can be combined with each of the possibilities for the dessert. Okay, so you could have chicken with ice cream. You could have chicken with fruit. You could have beef with ice cream, beef with fruit, pasta with ice cream, and then pasta with fruit. In total, you're going to have 1, 2, 3, 4, 5, 6 combinations. Right, but these are obtained from a multiplication, and hence the reason we call this lesson multiplication principle. Because each choice of the main course of which you have three versions can be combined with each choice for a dessert, of which there are two versions or two choices. So because of that, the total number of combinations really comes from multiplying the number of choices. That's the key thing. Each choice in the main course is pairs with each choice for the dessert. So that means you have 3 choices for the main course. Each of them is multiplied by 2 choices for the dessert, ice cream and fruit. It's as simple as that. The difficulty sometimes is combine the number of choices in each case or defining carefully the task, but it is really as simple as that, multiplying together all these choices. And by the way, you can expand this example for later. So let's say, for example, you want to have appetizer. You want to have the main course. You want to have the dessert. Then let's say the appetizer can be salad, or let's see, have what else? Salad and chips. Not too original, but 2 different appetizers, salad and chips. Main course, let's say again we have chicken, beef, and pasta. And then the dessert, let's say we have ice cream, fruit, and let's say cake. All right. So now, how many possibilities? How many combinations? Well, now we have 2 choices for the appetizer. Each of them can be combined with 3 choices for the main course, 3 choices for the dessert. 6 times 3, 18 combinations. Now, when it comes to figuring out the number of choices or the number of possibilities for each choice, we have to be careful sometimes. So here's my next example. Let's say someone is asking you how many numbers natural numbers, natural numbers with 3 digits. So if you think about in terms of a task, that is basically looking at possibilities for each digit. So you have basically a task that consists of a sequence of choices, right? I mean, you have choices for each place of the digit, for each digit in the number. And then you have to figure out the number of possibilities for each. But remember, no number starts with 0. So that means the number of choices for the first digit is n, while for the other 2 digits is 10, right? Because the first digit can be 1, 2, 3 up to 9. 1, 2, 3 all the way up to 9. And whereas the other 2 digits can start from 0, 0, 1, 2 all the way up to 9. So to apply the multiplication principle correctly, you got to be careful and figure out the number of choices, because it may not be obvious, or it may be some limitation hidden in the problem, right? So natural number with 3 digits, the first digit should be either 1 to 9, so you have 9 choices. The other one can be any digit, so it can be 0. So all the numbers that are possible here, of course, is 9 times 10 times 10. So again, just like before, you multiply the number of choices for each selection, basically. So in the next page, I'm going to write down in some words, the multiplication principle, and then we're going to go over a couple of more examples before we call it a day. So stay tuned for the next page. All right, so let's write down what the multiplication principle is as a general principle if you want. So let's say we have, if a task consists of a sequence of choices in which there are x1 selections for the first choice, x2 selections for the second choice, and so on, then the number of possible tasks, so then the number of possible tasks is x1 times x2 times x3 and dot dot dot. It's what we did before, right? So like I said in the previous example, choosing counting the number of digits, counting the number of natural numbers of 3 digits, it's equivalent to a task consisting of a sequence of exactly 3 choices. And then you multiply the number of selections for each choice. 9 for the first choice because it's the first digit, it can be 0, and then 10 for the other 2 choices. We still have to be careful and be creative when we do this counting using this multiplication principle. So here's an example in which we have to be careful not to miss, not to overcount or undercount, depending on the case. So suppose, for example, we have 4 teams in a sport, let's say 4 teams A, B, C, and D. And the question is, how many matchups possible? How many possible direct games between any 2 of them? So if you think in terms of the multiplication principle, the task is to have a sequence of 2 choices. And then write down the number of possibilities for each choice. So that's team 1, team 2. And then you can say, well, there are 4 teams in total. Each of them can play with the other ones. Now, and pay attention here, now once you look at a given team, the team cannot play with itself. So teams cannot play, a team cannot play with itself. So that means team number 2, you always have 3 possibilities for the second team. So the number of selections depends basically on the obvious assumption that a team cannot play with itself. So one has to be careful how we count these possibilities, right? Any 2 teams can play with each other. So the first team in the game can play, can be any of the 4 teams. And then that team can play with the other 3. And you may say, okay, well, good, then I have 4 times 3 equals 12 possible matchups. But is that really true? Because look at what happens. If you actually write down these possibilities, so team, if I have team A that can play with B, C, and D, then I have team B and that can play with A, C, and D. But notice that this match between A and B or B and A, it's really the same match. So it's not a mistake to use the counting principle or the multiplication principle, sorry, but be aware that by applying the multiplication principle in this form, you counted each match twice. Because in the way you do this multiplication principle, basically you take it separately as a match between A and B and B and A. That's not a tragedy, but that means the correct answer is really 12 divided by 2, which is 6 possible matchups. We're going to have stronger tools to deal with later to distinguish when the order matters, when it doesn't matter. That's an important thing to keep in mind. And sometimes the problem mentions, sometimes it's implicitly understood that it matters or not. See, the problem doesn't say the order doesn't matter, match between A and B or B between B and A. It's supposed to be understood implicitly that a matchup between two teams is basically putting those two teams in a field. Doesn't matter which one is mentioned first. So because the multiplication principle doesn't distinguish between the order of takes the order between them separately, we need to divide by 2 so that we eliminate the duplicates, so to speak. By the way, in case you're not convinced, all the matchups possible are AB, AC, AD, BC, BD, CD. These are all possible matchups between 4 teams. Here's another example in which we have to be careful when we figure out the number of selections. Let's say we have a group of 4 candidates to a job. And so these candidates are A, B, C, and D, just like before. In how many ways can we rank the candidates? So what is the selection here? I'm sorry, the task here. Well, the task is to place candidates in the first, second, third, and fourth positions. All right, so how many possibilities do we have? Well, for the first position, any of them can be the first, right? Again, let's just assume that any of them can be in any position. So you have exactly 4 choices for the first selection. The other way around. 4 selections for the first choice, right? For the first place in the rank. But that means you're left with only 3 choices for the second one. I mean, once one of them is placed in the first position, there's only 3 available that can possibly fill in the second position. And then once that's established, there's only 2 of them left to fill in the third position. And then once that's filled in, there's only one place, one possible selection for the last choice, for the fourth place. Again, a person, the key thing is that the person cannot be in 2 or more places at the same time. All right, so that means the total number of ranking, so the number of rankings using the multiplication principle is 4 times 3 times 2 times 1, which is 24 in this example. This quantity will appear often, this multiplication of all numbers from 1 to 4. This is called the factorial. So if n is positive integer, n factorial, also denoted by n followed by exclamation point, is 1 times 2 times 3 all the way up to n. Basically the number of rankings of set like a group of n candidates is going to be n factorial. 1 times 2 times 3 all the way up to n. So that's it for today. I'll see you next time.